Hi guys, my name is Jasmin Gonzales of BSCE 4B, and I'm going to discuss to you about the triangulation. First, let's start with the definition of triangulation. So triangulation, it is the process of measuring the angles of a chain or network of triangles formed by the stations marked on the surface of the Earth. The system consists of a number of interconnected triangles in which the length of only one baseline and the angles of the triangles are measured very precisely, which are used to calculate the coordinate of vertices. Next is the principle of triangulation. If all the three angles and the length of one side of a triangle are known, then by trigonometry, the lengths of the remaining sides of the triangle can be calculated. Again, if the coordinates of any vertex of the triangle and azimuth of any side are also known, then coordinates of the remaining vertices may be computed. In certain interval, check lines are measured to compare its computed length and check out the error. The lengths of the sides are calculated by using sine rule. Sine A upon A is equal to sine B upon B is equal to sine C upon C. In this figure, AC is equal to B is equal to C times sine B over sine C. And BC is equal to A is equal to C times sine A over sine C. From the triangle ABC as shown above, AB is the baseline whose length is known for measurement. All the angles are also measured. Now, other sides of the triangle are computed as follows. Now, computed sides BC and CA are used as the baseline for computation and other triangles. For example, AC is used as the baseline to compute the lengths of the sides AD and CD in next triangle ADC. Next is the objectives of triangulation surveys. The main objective of triangulation is to provide a number of stations whose relative and absolute positions, horizontal as well as vertical, are accurately established. More detailed location or engineering survey is then carried out from these stations. The triangulation surveys are carried out, number 1, to establish accurate control for plane and geodetic surveys of large areas by terrestrial methods. Number 2, to establish accurate control for photogrammetric surveys of large areas. Number 3, to assist in the determination of the size and shape of the Earth by making observations for latitude, longitude, and gravity. And number 4, to determine the accurate locations of points in engineering works such as A. Fixing center line and abutments of long bridges over large rivers. B. Fixing center line, terminal points, and shafts for long tunnels. C. Transferring to control points across wide sea channels, large water bodies, etc. D. Detection of crustal movements, etc. E. Finding the direction of the movement of the clouds. Then we have the classification of triangulations. First is the basis of the classification of triangulation figures is the accuracy with which the length and azimuth of a line of a triangulation are determined. On the basis of quality, accuracy, and purpose, triangulations are classified as number 1, primary or first-order triangulation. Number 2, secondary or second-order triangulation. Number 3, tertiary or third-order triangulation. A. Primary or first-order triangulation. It is the highest grade of triangulation system to determine the shape and size of the Earth's surface or to provide precise planimetric control points to which subsidiary triangulation may be connected. Stations of the first-order triangulation are generally selected 16 to 150 kilometers apart. Every possible precaution is taken in making linear, angular, and astronomical observations and also in their computation. Number 2, secondary or second-order triangulation. The secondary triangulation consists of a number of points fixed within the framework or primary triangulation to provide control points closer together than those of primary. Secondary is classified if primary does not attain standard of accuracy. The stations are fixed at close intervals so that the sizes of the triangles formed are smaller than the primary triangulation. Third, tertiary or third-order triangulation, employed to provide control points between stations of primary and secondary order series. The third-order triangulation consists of a number of points fixed within the framework or secondary triangulation and forms the immediate control for detailed engineering and other surveys. The sides of the triangles are small and instruments with moderate precision may be used. For topographical details, tertiary triangulations forms immediate control points. We also have the layout of triangulation. The arrangement of triangles of a series is known as the layout triangulation. A series of triangulation may consist of number 1. Single triangles in chain. 2. Double chain of triangles. 3. Braced quadrilateral. 4. Centered triangles and polygons. So first is the simple triangles in chain. This layout of triangulation is generally used when control points are provided in narrow strip of terrain such as valley between ridges. Rapid and economical due to less number of stations to be sighted. Do not provide independent check. Check baselines and astronomical observations for azimuth at frequent intervals. Second is the double chain of triangles. It is used for covering the larger width of belt. Third is the braced quadrilaterals. It consists of figures containing 4 corner stations and observed diagonals. Triangles are overlapped. Best arrangement of triangles as it provides a means of computing the lengths of sides using different combination of sides and angles. The last one is the centered triangles and polygons. It consists of figures containing centered polygons and centered triangles. Used when vast area in all dimensions is required to be covered. Figures are quadrilaterals, pentagons, or hexagons with central stations. So let's have an example. In a triangulation survey, 4 triangulation stations A, B, C, and D were tied using a braced quadrilateral ABCD. Shown in the figure. The length of the diagonal AC was measured and found to be 1,116.40 meters long. The measured angles are shown below. So for alpha, we have 44 degree, 40 minutes, and 59 seconds. For beta, we got 67 degrees, 43 minutes, and 55 seconds. For gamma, we have 63 degrees, 19 minutes, and 28 seconds. For delta, we have 29 degrees, 38 minutes, and 50 seconds. So the length of AC and angles of alpha, beta, gamma, and delta are given. We have to calculate the length of BD. Here, we have the expressions for sine rule and cosine rule. These are the main mathematical fundamentals which are used to solve this problem. Now, let me explain the solution. As we know, the summation of interior angles of a triangle is equal to 180 degrees. First, let's consider the ABD triangle. So we have the angle of BAD equals to theta equals to 180 degrees minus alpha plus gamma. Alpha and gamma values are given. So we have theta equals to 71 degrees, 59 minutes, and 33 seconds. Similarly, in BCD triangle, we have phi equals to 180 degrees minus beta and theta. Beta and theta values are given. So we have 82 degrees, 37 minutes, and 15 seconds. Now, let's apply the sine rule into ABD triangle. We have AB divided by sine gamma equals to BD divided by sine theta. Then AB equals to BD into sine gamma divided by sine theta. It's noted as equation A. Similarly, apply sine rule into BCD triangle. We have BC divided by sine delta equals to BD divided by sine phi. Then we have BC equals to BD into sine delta divided by sine phi. It is also noted as equation B. Now, Considering the ABC triangle, the length of AC is given and AB and BC are known in terms of BD. And the angle of ABC is equals to alpha plus beta. Now, applying cosine rule in ABC triangle, we have AC squared equals AB squared plus BC squared minus 2 times AB times BC times cosine ABC. It is noted as equation C. Now, substituting the values of AB and BC from equation A and B respectively in C, we can get this equation. Then taking out BD squared as common, we have this equation. So the length of AC is known, the angles alpha, beta, gamma, delta, theta, and phi are known. We know the angle of ABC equals to alpha plus beta, so we can put those values in this equation. The only unknown is length of PD. So finally, after solving the equation, we have the length of PD equals to 914.89 meter. This is the required answer. Thank you.